arena globally. Then we will move into local regulation. Then the industry presentations on shipbuilding and an example at the end as a successful example. So let's start up with maritime decarbonization. Before start, I should like to underline very carefully, maritime transportation is one of the most efficient transportation means for GHG emissions. Why? Simply, for the carriage of cargo, the tankers and bulk carriers, emissions is only 1/90 of air transport. So air transport produces 90 times more emissions. If you look at in this side, we can say maritime transportation is one way to reduce the emissions all over the world. Second point, the total emissions produced by the maritime transport is only about 11% within the transport arena. 80% of the cargo is carried by the maritime transport, but only 11% of the emissions. We need to go back and start up from the main principle. The principle is the fossil fuel consumption is the main reason behind the emissions in the maritime industry. If you are in a land transport, there are other options. But in case of an international maritime transport, this is not possible. And let's not forget, 1 ton of petrol products, which can be a heavy fuel oil or it can be diesel oil, produces 3.2 tons. That means we are actually increasing the quantity by the consumption of the fuel. There are lots of rumors saying that LNG is a solution, which is not, unfortunately, because LNG's emission potential because of the fuel consumption is 2.75 tons instead of 3.2. So only about 20% reduction can be achieved by use of LNG. So what is the drives behind the decarbonization of the shipping? There are different ways to look at it. First, we can look at from the energy efficiency. Secondly, we can look at from the new alternative fuels, which will be different from a road transport point of view. And lastly, we can talk about carbon capture. What are the obstacles? The first obstacle is the production of the alternative fuels. Storage difficulties, non-availability, lack of experience, and finally the cost. People are talking about utilization of hydrogen as a fuel on shipping. That isn't an easy process because these problems makes it almost impossible for now. So the projections, the pathways are being lined up for 2050. What is driving it? Which I will be talking briefly, is IMO regulations and the driving force of the EU, Green Deal mainly, and the charterers and financial companies. Poseidon principles is a necessity nowadays for any maritime transport financing mechanism. What are the technical measures? The regulation nowadays is international. Why we are talking about international regulation? There is a simple reason. Maritime is not included in countries' own promises for GHG reductions. As it is international business, it is actually has to be dealt in internationally. An international maritime organization produced 2 regulations up to now. One of them is energy efficiency of the shipping. Secondly, carbon intensity indicator. And the new process is continuing for alternative fuel life cycle analysis and as well as market-based measures. Let's look at them very briefly. Energy efficiency of a ship is normally conducted at calm water. Don't worry about the equations, but it's a constant thing. It is once a time. How to improve it? There are a number of ways. We can talk about improving the ship efficiency. We can talk about engine efficiency, changing of the fuel, that is a discussion nowadays, increase of capacity, innovation, or probably the only solution available, which is green, is the engine shaft power limitation. What is engine shaft power limitation? Simply reduction of the speed. Unfortunately, the technology we have all over the world is only sufficient to reduce the GHG emissions by reducing the speed. This is somehow not a nice point of view. These points indicate the criteria for EEXI energy efficiency regulation. The red line is the border. If you are above, not satisfied. If you are below, the ship satisfies the regulation. The green and blue dots are Turkish ships. And as you can see, about 72% cannot satisfy. And the first point would be immediately, Turkish ships are in a bad position, which is not true. The black lines are all other flags. So all over the world, the technology, without discrimination of the flag, has got difficulties for energy efficiency design index. And only solution up to now, reduction of the speed. A reduction of the speed in turns requires more ships, hence more emissions. The second is a new regulation coming along for the 1st of January. And it is based on putting the ships in an A, B, C, D, E scale, just like our fridges. And this will be based on consumption of the fuel every year. And the difference between a refrigerator and a ship is going to be, refrigerator is classified before going into the market. But in case of ships, they will be marked after the yearly consumption of the fuel. So they will be polluting or they will be creating emissions. After a year, we will find out. Improving is possible with operational and technical efficiency increases, but carbon intensity indicator is going to change every year. That means as the years goes by, if we go along the years of 2030, this is not going to be enough. So only in short term we can satisfy it, but in the long term, the only possibility is to produce low carbon fuels. That's another graph of Turkish ships satisfying CII. Only 46% satisfies. Exactly the same for world fleet. So the problem is a global thing. IMO's regulations mainly produces technical rules. Alternative regulation coming along with EU. And EU ETS is an exception that includes only transport mode of maritime. The new regulation will come into force probably in 2023, and it will bring out a cost increase for any consumer. For all ship travels to Europe and from Europe will be somehow, I would call it, taxed, because it's called ETS, emission trading system. However, there is no allowances. Everybody pays. All polluters pays. So it's actually a kind of a tax. But the tax rate is found from European emission scheme. What is the cost for Turkish side? At least 125 million euros per year. If the EU Parliament revision is accepted, is about 250 million euros per year for Turkish ships only. And if it is globally applied, it's about 900 million to 1 billion euros per year. So it's quite a lot. And the new regulation is coming along with Feel EU Maritime that is based on the carbon content and also the shore power connection is required for ships in ports. Now, this is an important item here because the last presentation is going to deal with it quite a lot. Normally, you cannot use electricity for ship propulsion. Only in case of imports or some local ships. So this is a new requirement, well to wake, looking into the fuel life cycle of the fuels, rather than what is being consumed in the ship, how it's being produced. It actually really means how that fuel is produced. Saying that use of hydrogen is quite a nice view, but whether can we produce that hydrogen from a green sources is the main discussion nowadays. Okay, so what is available as a fuel? I can only say only this part is available, which is wind, electric, fossil fuels, little bit LNG. The rest is not really available. So when we talk about alternative fuels, that is not really available at this moment of time. When we look at the ships being built, only about 1% with alternative fuels. So let's not put ourselves in a dream that the ships is going to use alternative fuels and it's going to be emission free in 2030. That is not going to happen. There are lots of technical problems with the new fuels. I won't talk about them, but for a technical people, for engineers, these are huge because the hydrogen is stored in minus 270 degrees in a high pressure, and this is like a bomb in a ship. Now, the main question is, when these regulations are active, whether there will be green alternative fuels, that is a big question. Whether the carbon capture is a viable option. We have destroyed the forests and now we are trying to produce some industrial facilities for carbon capture, which is a big dilemma, and maybe an option to go back to wind propulsion for the future. The wind energy is an option nowadays. I will go 2 more slides and finish over there. Retrofits is an option. Why it's an option? Because energy efficiency is something we can achieve now. Things like gate rudder option, that is the first retrofit in the world, is being done in Turkey nowadays. So we are in lead in this sense. Combining of options such as gate rudder, air lubrication, operational measures, and wind can achieve about 50%, which is available now. Now, the question is, with these regulations, how much we do adopt in our regulation is the first question. And secondly, whether we can produce the ships for that purpose. Now, I'm going to give the floor to Nazan Özürek to talk about the Turkish side of the regulations. What we are doing on the maritime side for the Turkish national regulations. Please.
Thank you very much, Mr. Chair. Distinguished guests, ladies and gentlemen, I would like to welcome you to our side event. I would like to make my presentation on the environmental management of shipyards, since we have a study in order to make them have regulations. But before I start, I would like to mention the relationship between the good environmental status of marine environment and the climate change. Since marine environment, seas, oceans are the main carbon sink, and we have to increase the carbon sink capacity of the marine environment. All of the efforts to make it cleaner contribute to mitigation with climate change. And climate change and marine environments have a closed loop of cause and effect. marine environment and marine ecosystems are mostly affected by the climate change. So our efforts to mitigate and adaptate to climate change via having marine regulations. First, in my presentation, I would like to explain the measures concerning shipyards, and also I would like to explain how we make the decision-making process and legislation regulation-making process. We consider especially these sectors during decision-making in the scope of the life cycle assessment, because this is very important, also in terms of climate change, but in terms of environmental management. The first step for the maritime industry is design. Design of ships, design of shipyards, and the others. Because all of the issues, not all, but some of the issues were related to design, as Mustafa said, also mentioned for the ships. The construction, this is the main issue of my presentation. I will explain in detail. We consider also the operational part and scrapping. The operational part, we have a lot of national and international regulations that we have IMO decisions. We are all applying these regulations. And for scrapping, there is Basel Convention and our national legislation, and we have environmental measures in terms of these. Now I would like to explain the environmental impacts of the shipbuilding and the measures we developed. Shipyards are very important for Turkey. We have 84 shipyards now. On the map, you can show, I illustrated the main districts of shipyards. There are all around the Turkey. We have shipyards in all our coasts. When we consider shipyards, this is a part of decision-making process. We are trying to understand the processes that they have in. For the shipyards, mainly we categorize them in 5. They have machining and metalworks. They have surface preparation, painting, metal coating, surface processing, and we have fiberglass manufacturing of boats that are we have processes we have in the shipyards, and the the fiberglass part. We have these production in our shipyards. In order to understand the situation and make the legislation, we performed a project. On the screen, you can see the flowchart of our project. I will explain in short. First, we started with the inventory, what we have in the hand. Then we review all of the national and international legislations, conventions, directives, and go through them. We examine the process, their processes, and the possible pollutants. Then we determine the environmental quality status. I mean, we determine the environmental quality status of sea, which we have the shipyards, mainly the most crowded districts are chosen. Then we go through cleaner production options for shipyards. This is the most crucial part of this study. We try to cover the literature, but we go on site and try to develop some. And then we determine the environmental measures, considering these cleaner production techniques and considering mainly the good environmental status of the seas. And then we develop some environmental monitoring methodology. I will explain some in detail. We go through some cleaner production options. That means we consider first sound environmental management of these shipyards. These are mainly administrative measures. Change of production materials is an option. It includes the design and the production and the recycling material part. We try to go through better process control. It includes the wastewater, water usage, waste management parts. So we develop some better options for the management of these parts. Equipment modification, because the production processes are more or less the same all around the world. This is mainly about the energy. Energy modifications means having cleaner energy. Whether it comes from the fossil fuels and the renewables, and mainly the energy efficiency of the equipment. We go through the technology change. Green shipbuilding techniques will be new. The innovative technologies are determined in this scope. On-site recovery, varied applicables. We go through it. Reuse of waste materials is another. We go through also energy from waste option. And then we go through at last product modification, which is mainly about the ships. The modification of the ships, considering ballast water, energy usage, and kind of. So we prepared the draft legislation. It's at the last, we have the last version in hand. The main aim we categorized them for, they are mainly grieved. The main aim is to improve and protect marine environment, to have the good environmental studies of the seas. We go through efficient use of energy. We try to reduce greenhouse gas and the other pollutant emissions, and we develop an implementation of renewable energy projects in the shipyards. The first measure is about the ballast sediment. There is a convention named Ballast Convention, and there is MARPOL Convention. They says you have to manage ballast sediment. In the ports, it's not available. So the shipyards at the point of the management of these ballast sediment. Ballast sediment means the sludge that we have in time under the ballast tank. So we have the measures. You have to have sediment reception facilities and necessary equipment. Our request is to have a licensing for this procedure for these. We want some sediment management plan to be applied in 5 years, annual reporting and training of personnel that will work at these processes. We go through the cleaner production options. We define some emission limit values for total organic carbon and dust. For the completely closed, new production zones. And we said that there have to be a tracking system to monitor the docks. And we want some main and intermediate drainage channels to make to avoid pollutants go through the sea directly. And for these water, the draft legislation requires oil separator and public filters. They are new for Turkey, and this is not that they have it in the literature. The other international or national legislations. And we want determination of waste storage area away from sea to reduce the risk. So, very applicable, we want dyeing to be closed. And the legislation wants performing surface preparation and painting in a closed and impermeable zone. Preferring renewable energy sources means all legislation considering best available techniques have musts and offers. This is offer. I can say very applicable. They have to use the renewable energy sources. This is the one that we the most related one with the climate change, directly related, not indirectly. Reducing the energy used 20% in 7 years. And electrification of the service boats in 5 years. This is about also carbon emissions. We want ballasting to be, we want them to choose one or at least one. It may be in a complete space, it may be surrounded. Wet ballasting may be an option, not commonly preferred. We want them to establish a dust collection system or use a suppression system to eliminate dust. And the last slide is about monitoring. Monitoring is a very crucial step because for decision making, you have to monitor in order to understand the effectiveness of your legislation. You have to monitor. In the slide, you can see that we want some marine environmental monitoring from different mediums in such frequency. The main aim is to, there is not a limit value for these, but we are trying to understand the situation. We will compare the results, annual results, and we are trying to see whether it goes worse or better or stays stable. And draft regulation also requires a report in order to understand whether their shipyards are applying all of these measures and how. So we want to monitor also the implementation of the draft legislation. We hope to publish them in a short while. Thank you very much for listening.
I would like to thank Ms. Nazan Özyürek for the regulations of the Turkish side. That will be hard times for the shipbuilders, I assume. Now we have the representation from the shipbuilder side, Ms. Mehtap Özdemir Karahallı. I will call you for telling us what is being done in the industry.
Thank you very much. I'm really glad to meet you here. Now I would like to give brief information about our approach as Turkish shipbuilding industry in the transition to low carbon shipping and some challenging projects and also state-of-art technologies in shipbuilding. As an NGO, as the Turkish shipbuilding industry, we have 600 years old tradition in fact. This is the oldest shipyard still under operation in the world. And as an association, we are one of the oldest NGOs in Turkey, and we are the member of ASF and Sea Europe, so we can present ourselves all over the world within other NGOs. In Turkey, we have really good infrastructure for shipbuilding industry, and we have 84 active shipyards now. And when we look at our infrastructures, we have 11 dry docks and 33 floating docks. So this means we have really excellent infrastructure for new building and as well as ship repair and maintenance. When we look at the alternative fuels and batteries in Turkey, in 2021, according to DMV statistics, the percentage of eco ships in new buildings is, you can see, as 11%. But in Turkey now, our percentage is 35%. So 35% of all new builds in Turkey are eco ships, eco vessels. Also, maybe we can talk about the key elements for proper transition to low carbon shipping. There are ship owners and there are regulatory bodies and also shipbuilding industry. For the proper ecosystem for transition, we can say that in shipbuilding side, we have some infrastructures and engineering and experience in shipbuilding, and also we have price quality advantage, on-time delivery, supply chain and reliability. So Turkey is one of the most experienced countries in new building for generation of low carbon ships and retrofits of existing ships, which complies with all of these key elements. We have low and zero carbon projects experience, which are about fully battery powered ships, highly energy efficient ships, LNG powered hybrid ships, and we can say that, we are proud to say that, some of them are the world's first vessels. I will give some examples at the later stage. And we have another example for new technologies, dual fuel methanol MDO HVO vessel. And there is a huge demand for increasing energy efficiency of existing ships by retrofits, such as lengthening of ships, propulsion steering systems, and hull form chains. And also there are some, as Mustafa Insel mentioned before, there are some technologies that we can use for existing ships and for new ships. New propeller and rudder designs and manufacturers such as gate rudder, twisted rudder, wind technologies, new alternative fuel engines, after treatment technologies, And also we have really experienced about scrubbers, exhaust gas recovery systems, and possible future technologies might be carbon capture technologies, not available yet, but I think we can see on ships in the near future, such as carbon capture technologies. These are the examples for passenger vessels that are built in Turkey. As you can see here, most of them are diesel-electric passenger ferries, and the largest zero-emission freight ferry, diesel battery upgrade to methanol. So if there is a change in the fuel, there's a possibility for the ship to upgrade to methanol. And the other example is the world's largest battery packs, hybrid-powered LNG and battery ship, which was another example. For the tugboats, we can say that we are really experienced about tugboats, and you can see the world's first battery-powered full electric harbor tugboat. And this tug is operates in Tuzla shipyard region as the world's first one. And now the second one is coming, and we will build 3 more. And the other example is the world's first LNG-fueled escort tug and the advanced variable hybrid tug. We are also experienced about offshore supply vessels. This example is the world's first hybrid battery vessel, and the other one is methanol marine diesel oil HVO powered vessel. And the other examples from supply vessels. For the fishing vessels, we can say that we have so many clients from North Europe, and they are really focused about GHG emission reduction. Because of that, the latest ships are dual fuel, such as LNG, biogas, potentially ammonia fishing vessels. This is the world's largest live fish carrier, and it is also hybrid and battery powered. And the other one is the world's first purpose-built vessel combined long-line and Danish seiner. This is the one, it's a unique one, direct LNG fueled one. And the other example is the world's first LNG battery-driven per-seiner trawler. We are the third in mega yacht building. Nowadays, I cannot give any example about hybrid or battery-powered yachts, unfortunately. But in the near future, we can see HVO battery-powered or methanol fuel cell-powered mega yachts, we hope, in fact. And also, I would like to give some innovative and environmental-friendly implementations from our industry. As I mentioned before, we are now operating the world's first all-electric zero-emission tug in Turkey in our Tuzla shipyard region in Tuzla port. And Gürdoğar will give more information about the project at the next presentation. And we have a question. What if we can decarbonize all tugs in the world within 10 years? We studied about statistics, and we can see that we have approximately 2,000 tugboats every year scrapped, and also most of them are really old tugboats. So there is a possibility to change all of these tugs. And if we can decarbonize all tugs with battery systems or any other alternative fuel, we can cut 5% of CO2 emissions compared to total shipping CO2 emissions. So it is possible to start reduction of tug GHG emissions as well as other coastal vessels emissions. You can see our project. The other phase of the project is decarbonizing of the other infrastructures, such as by using e-trucks, e-cranes, e-handlers, and also our Z-tugs. And we will use in the port the wind and photovoltaic panels. What about the shipyards? Nazan has already mentioned there might be some restrictions about shipyard studies. So we are really focusing about new alternative energies and also reduction of GHG emissions due to manufacturing processes. So some of our shipyards now using rooftop solar energy systems in their shipyards, and also some shipyards are changing their lighting systems. And also, as an association, we are a member of one Horizon 2020 European project. This is a new technology for shipbuilding industry. And you can see some other partners from the Europe, such as European Welders Federation, TU Delft University, Stirwelt, Aklunaga, Element 6. Now we are studying about application of friction welding technology to shipbuilding industry. This technology has some advantages in shipbuilding, as well as there is no consumable material for welding. So it's something like not using any consumable material. It's something like a forging operation. So there is no output, there is no consumption, and also the energy use is more efficient than classic welding technologies. And also we have conducted some life cycle inventory studies for various ship types, and we have uploaded this data to international database. So you can see some Turkish examples in international databases. And also now we are working on some proposed funds about World Bank and EU proposed funds. One of them is about EU EBRD blended finance opportunities for 4 or 5 small-scale pilot projects in Turkey. It might be about ports, ships, short sea shipping. And the other World Bank proposed project is about feasibility studies for decarbonization of ferries in Istanbul. It's really important. There is a possibility to decarbonize all ferries in Istanbul if there will be a budget from World Bank. And what we are talking about decarbonization, and there is a need for skills for engineers and also technical people. So because these ships are really complex, and there is a need for engineering, how can I say, the advanced technologies are really important. So all of the engineers and technicians need to understand state-of-art technologies in detail in order to comply functional requirements of the ships. And they need to solve possible risks due to new kinds of alternative fuels such as fire, explosion, noxious liquid, environmental hazards, corrosion and leakage, and deal with these complex design parameters. And also we are expecting software developments for integration of systems and data statistical analysis for operational behavior of ships, and life cycle assessment for ships, including shipyard operational impact. So there might be a need some really experienced people on that matters, and also 3D scanning technologies due to complex piping and installation needs might be very important in the near future. Thank you very much for your attention. And
I would like to thank Ms. Mehtap Özdemir. As you can see, Turkish shipyards is actually a source of eco-friendly ships for all over the world at the moment. So that's something we are proud of. Our last presenter, Gürdağ Sarıgül, is going to present you something else. The first we have done as Turkish shipbuilders in the world, which is electric tugs and electrification of the Turkish Tuzla ports. And the questions will be after his presentation.
Thank you very much. Yeah, as always happened to me, if you're on the last on the presentation, and then everybody's slightly moving out, but I hope the rest of is going to enjoy what I'm going to present. And there are 2 takeaways from this presentation. One is that the ports are important emission sources, and also the air pollution sources in the ports, which mostly they are very close to the towns. And second is that the decarbonization of the maritime sector, it should start from the ports, because they are very much important in terms of human life and settlements. Well, already Professor Insel said, and also Mehtap talked about some of the slides is going to be repetition, that I'm going to a little bit go faster on that. The GİSBİR port project is related with the Tuzla shipyard area, which is along the Istanbul coastline towards the Kocaeli region to the east. It's a shipyard, consists of a lot of shipyards and primarily focus on ship repairs, refitting, and the partially construction. And GİSBİR is the joint venture of all the industrial installations which are placed in the Tuzla area. Well, the major emission sources in the ports that our project was inherited, because when we look at the source of the pollutions in terms of GHG plus other pollutions like SOx and NOx, all the pollution related with the diesel engines are mostly coming from tugboats and workboats which are operating in the ports. And if you think that all the ports are very close into the cities, and some of the research tells about that around 60% of the air pollution comes from the ports which is within the city boundary of the most of the populated areas. And in our case, we have checked the pollution and also emission sources in the GİSBİR sample port in Tuzla region, and we found out that nearly 76% of the emission comes from the port reference. And the project developed on a way that, aiming to reduce the GHG emission in the maritime sector, which leads later on the decarbonization of the maritime sector. And for this project, we wanted to have a kind of best example about the kind of innovative actions and the technology that a port can do and then reach decarbonization. And there are several outcomes that we expect from this project. Firstly, we want to cut all the emissions in the port. And secondly, we would like to deploy all the electric vessels for the port work, for the tugboats and also other workboats. And then at the end of the day, that they increase the global awareness about the maritime decarbonization is an important element. Also, it can be happen. And the project is designed in a kind of 4 different phases. And first start with the electrification of the tugboat, and then later on changing all other vessels and also the all other winches and everything into electrification, and also increase the capacity of the port. But at the end of the day, the project aims to reach completely decarbonized port in GİSBİR port. And as already mentioned, that this is the world's first fully battery-powered tugboat. We call it Z-Tug. It's a kind of brand name. And this has been sort of very famous all over the world. It received a lot of awards, international awards. And it is already the only one example working all over the world in any single port. And this makes a lot of uniqueness for this project, as Mehta was mentioning that the second one just met the water last week, and there are 2 more under construction. And this is like a Tesla in the water in terms of maritime sector. It's an extremely important innovation, also the showcase. And the full electric tugboat, which has already now more than 2 years under operation. And there are a lot of significant benefits in terms of operation and maintenance cost. And we have something like more than 50% of the fuel cost. And the total maintenance and repair cost is almost 80% less. And this has a very important element for the operator of this kind of vessels, because when you have these vessels, that means you don't have any problem most of the time, and the problems are much more easily be solved because everything is electric and electronic, and you have only one single, very simple electric motor at the end of the day. And well, after so many working operation days, we calculated that how much emission we saved. And in total, around annually, we are talking about 200,000 tons CO2 emissions saved. And since it's an electric motor, there is no all other diesel-related pollutions like NOx and SOx and all PM particle matters, and which has a completely zero emission in that sense, and it has a lot of impact on the human health, because we are not talking only about the GHG emission, but we are also talking about the cutting pollution, where we have a lot of problems when we sort of exposed to diesel exhausts. And to link to that Z-port, which is, we call it zero emission electric port, and we run a case study to see if this is going to be feasible investment and how we can make a port completely decarbonized. And then we look into the typical energy requirements for the type of operations in a given port has, and there's 48% equipment and vehicles, which all includes tugboats and workboats or other moving works, and you have operational systems like cargo handling, port access, and the lightning, cold ironing, which is the onshore electric power for the vessels, and then buildings is 17%. And we did a kind of estimation about the energy consumption, and at the end of our calculation, we're talking about 20,000 kilowatt hours energy consumption, which is distributed along the other different type of operations in the port. And then we calculated that how are we going to provide the required renewable energy in order to meet with this demand. And then we studied, and we assumed that we will have a 2 megawatt hours solar power plant, and that would generate annually 3.5 megawatt hours of electricity and 5 megawatt hours of wind. And then calculations led to us to see how we can get there. And at the end of the day, and our renewable energy production is going to be more than what the port is needed annually. And that will also give us a kind of surplus electricity that we could sell to the grid, or we could alternatively store it. You can store it in the lithium-ion batteries, or also you can store it in the hydrogen form. That's a kind of possibilities that we can store energy. And at the end of the day, we calculated how much it's going to cost to us for this investment. And our calculation, which is a bit outdated, this calculation, because also in the Eurozone, we are talking about minimum 20% of inflation for the whole equipment on anything you buy it. But that the time that we estimate about the 42 million euro investment needed. And the question is, and how are you going to get this money back when you invest it in this one? And there are a lot of savings when you invest in the fully renewable energy systems in a given port. And then you sell some of the energy, you save some of the, because you don't use diesel and other things. And there are a lot of savings. And when you calculate it, it turns out that you make a kind of 7.3 million euro revenue annually. And when you put everything together in the cash flow table, and then you see that as a kind of remarkable return of investment of your investment is just a bit more than 5 years. And this was a kind of conclusion to, in our case, that the investing in a decarbonizing of a port is going to be economically feasible and also environmentally very effective and beneficial in terms of cutting emissions down, also improving the air quality where the old port is in operation. And I'm done. Okay, I hope. I'm in the. All right. Thank you very much.
Thank you very much, Kurdar. As you can see, it is one of the sectors we lead on decarbonization in the world. Is there any questions, please, for any of the presenters? No? Okay. Thank you very much for listening. I would like to invite all the speakers here, Mehtap, Nazan, and Gurdar. Aman. Thank you very much for listening us, and artık ben takdim edeyim.